Activate. We are now live, so to speak. Take out your worksheets. Have a red writing utensil at the ready. Hi everybody at home, I'm off screen. I'm here. I'll be on screen in about 5-10 minutes. And let's see what we got for answers. 4C-5, number 1. I'll give you x equals y equals. What you might have as an answer might be a matrix, which is okay. The only thing I would say is if you get an answer like this, like I'm just making this up, 2 and 7, on the test, what I would ask you to do is label these as x and y. They will come in alphabetical order from top. Whatever order you put them in the problem, they'll come back to you in the solution. So hypothetically, if somebody were strange and reversed all the x's and y's, they put the y's first, then x, the number, you'd get the y first, then x, the number. So if you write it normally in normal standard form, and you get a matrix as an answer, ta-da. So Cramer's rule, I don't think you'll have to worry about that, but on inverse matrices you would. Number 1, x equals -2, y equals -6. Number 2, x equals 8, y equals -24. And do keep in mind, it does say use Cramer's rule to solve these. So I've seen some people in the middle of a test get rattled and then say, you know what, I'm just going to solve by elimination. That won't work on this particular problem. I will say, solve by Cramer's rule, no credit for other methods, show your work. So make sure you know how to do this at least a few times. I did number 2 already? Okay, number 3, 11 over 20 for x, and y is -27 over 20. And repeat so far. Yeah. Number 3, yeah, x is equal to 11 over 20, y is equal to -27 over 20. So if that doesn't match yours, that goes in. And number 4 we did in class, but it's x equals -13 over 3, y equals -13 over 3. And it repeats. Questions? Anybody want to see those dissected too? Number 1, yeah. Let me just carry this and give myself a whiplash right now. Hopefully everybody can see this on screen. 5x minus 6y equals 26. -2x plus y equals -2. Now, quick 45-second infomercial for the people watching at home. There are a few things we'll need to know. First is how to convert to a matrix equation. That means the left-hand side is going to be matrix A, just the coefficients. Can somebody do that for me? What is matrix A? It'll be matrix A, a smaller matrix X, and then matrix B is the answer matrix. Tell me what goes in matrix A. Right. -6, -2, and what? 1. And a 1. Good, because there's a 1 in front of the y. This should be what? So, x and y, in that order. And go ahead and do the other one too. 26 and -2. Does that make sense? So if you can take a system of equations in standard form and translate them into a matrix equation, Cramer's rule can work for you. Second thing is a reminder. You'll need to know how to use position signs. Now for a 2x2, position signs are what? Josh.
This would be plus, minus, plus, minus.
Which one?
Minus.
Minus and then plus. It always starts in the upper left with a plus, and then it alternates across and alternates up and down. So the way to double check is make sure the diagonals all have the same sign. Okay? Now, these are the position signs we might eventually need. You'll also need to know how to do a determinant. We talked a bit about this last week, But for a 2 by 2 determinant, if I were to give you A, B, C, D, can somebody tell me how to calculate the determinants? Becca.
Would be AB
Uh-huh.
minus BC.
Minus BC, or CB, whichever way you want. So a nickname for that is downhill minus uphill. So the downhill slope minus the uphill slope. Just be careful. One of the most common errors last year was that people would do AD plus BC by mistake. It's always subtracting in the middle whenever you're doing a determinant of 2 by 2. Okay? You'll need to know how to do those, but there are, for Cramer's rule, we need to find 3 determinants. Can somebody name the 3 things we have to find the determinant of? There are 3 special matrices. Can somebody name them? Great. A sub x, and A sub y. If you can get those, you're done with Cramer's rule, pretty much. There's just one extra step beyond that. What is, now what do these straight bars mean again? Okay. Recording. Yeah, what do those straight bars mean?
I don't remember the name. Or
Determinant,
determinant.
very good. It looks like absolute value, but you're doing it around in a matrix. It's called a determinant. So Courtney, last question for you. What do I put in here?
5, -6, -2.
Right, the original matrix. 5, -6, -2, and 1. Go ahead and calculate that for me if you would.
It would be -6.
How do you get it?
Oh, 5 minus 12.
Yeah, 5 times 1 is 5, downhill. So you multiply downhill, I'll show it once just for the people at home, minus -2 times -6. So it's really 5 minus +12, which is -7. Does that make sense? So, Nate, take over. A sub x. I'll leave a hint. X, if you look at the original equation, this is the x column. And this, shocker of shockers, is the y column. Why do I mention that? A sub x, you see this matrix B? We're going to cut and paste it into matrix A in either one place or the other. This will tell us which one. So start with regular A. What's in here? What's the x column? What 2 numbers? 5 and -2. What's the y column? -6 and 1. Here they want you to swap out the x column with this. So tell me what the new x column should be.
26, -2.
Exactly. And then leave the other ones alone. -6 and 1. Does that make sense? Calculate it for me. Downhill?
26.
26 minus what?
Minus 8. 40 plus.
Minus +12, correct. What is 26 minus 12? 14. Good. Does that make sense? And then Will, take over. What does this mean?
So that's the absolute value of AY.
Not absolute value, but
Huh?
not absolute value, but different
Oh,
word.
did I say absolute value?
You did.
I meant determinant.
Determinant, good.
So
So-
it would be 5,
Uh-huh.
and then -3,
Okay,
and then 26.
good. The y column got swapped out this time with this. Go ahead and calculate that while we're at it.
Okay, so -10.
Good.
Minus.
Minus, oh, this is fine.
52.
Almost.
Or, sorry, -52.
Minus -52. What's minus a negative?
That's a positive. So
Positive.
-10 plus,
Good. What do you get?
42.
42. All the hard work is done. Can somebody tell me how to get x and y? They're both fractions. Go.
You put the answer for the a sub x over a.
Determinant of a sub x over determinant of a. Go ahead and do that for me.
That'll be 14 over -7.
What is 14 over -7?
-2.
-2. And give me the y. Okay. How do you do that? It's, exactly. Determinant of a sub y over the determinant of a. Go ahead and do that for me. So a sub y we already did.
Oh,
42,
over,
negative 7. What is that? I'm sorry? Negative 6. Got it. Questions? Everybody feel okay on that? Could you do that if I give it to you on a test? Fine, Dan. Any other questions? Yeah.
Could you go over number 3?
Number 3, sure. Now, did everybody have this one? Can I erase it? Okay, speak now or forever hold your peace. I now pronounce you Alg2. Okay. Let's try and see how fast Cramer's rule can go. I'm not trying to lose anybody, but I do want to show you how fast Cramer's rule can go. It's very useful. Negative 2x minus 6y equals 7. So if you're called upon in the wild, so to speak, to do one of these, negative 6x plus 2y equals negative 6. Here's what I would do immediately. If I'm doing it on a test, I would say, aha, determinant of A. I just lift these numbers out right away. Negative 2, negative 6, negative 6, 2. And I'll calculate that right away. Downhill is negative 4 minus positive 36. So it should be negative 40. Are we okay? You're actually a third of the way done. Now, A sub x, it takes this answer matrix and swaps it in for the x's. So the new x column is going to be 7, negative 6, and then these other ones are going to stay put. Still okay? Downhill is 14 minus regular 36. I'm going to add the opposite for that's me. That should be 22, maybe 22, I hope. And then A sub y swaps out the y column. Is that the fan doing the chirp, chirp, chirp?
No, that's just,
Oh, I feel for you. Okay, that's fine. Okay, don't encourage it. But, so this one is negative 2, negative 6, and then this swaps out for 7, negative 6. So regular 12 downhill minus negative 42. I'm going to add that out. This is 54. The two answers, the solutions, are A sub x over A, and y is A sub y over A. Now you do have to reduce. Negative over negative is positive. This is 11 over 20, and this is negative 27 over 20, I think. And that's it. Does that make sense? You feeling okay with that? Number 2. Did anybody find the trick to doing this? Something's missing. Now be honest, did anybody just say, oh man alive, what a softball. Just divide the top by 2 and get x is 8, yay, and then plug it in and get y? Okay, good. That would have worked, but that's not Cramer's rule. What's the secret to fixing it with Cramer's rule? Get
Put the 0 in.
2x plus 0y. Yeah, you need a 0 for the y slot on the first line. Then Cramer's rule should work. Feeling okay? Okay. Go ahead and put that away for now. Take out your notes. By the way, tomorrow's assignment is going to be to finish this worksheet. So the back page. I do have to warn you about a few things though. There are some strange solutions that show up. That's the main focus of today's notes. I do also want to show you a little taste of how Cramer's rule can work with other things. But first things first. Example. Solve with Cramer's rule. Uh, 7x minus 3y is equal to 14. And then negative 21x plus 9y equal to negative 42. And yeah, some of the numbers are big. So jot that down. 7x minus 3y equals 14, negative 21x plus 9y equals negative 42. And can somebody set this up for me? What do you do first? Yeah. Right, determinant of A. So what would you get? Oh, you could definitely do the other steps too.
Okay.
Sorry, I actually kind of turboed, sorry.
No, that's okay.
Just go ahead and lift these out.
Yeah, so it would be
7. Negative 3, good. That's why I had subtraction, by the way. Well, one of many reasons. Negative 21 and 9. That's matrix A determinant. We'll get that in a second. Can somebody tell me, just by visualizing, what is A sub x determinant? Rainey, take over. Which column is getting swapped out? Yeah. So what should the new? Yes. And what are the other ones? Yeah, the same as they were before. Can somebody, actually Courtney, tell me A sub y. What's getting swapped out? The y's. Tell me what the first column is.
7,
Good, that's the original. And then 14, negative 42. Anybody feeling brave to calculate these by mental math? Don't all beat me out of the way and get up to the board. Spencer, calculate the top one for me. Downhill. 63. Minus what? Interesting. What do you get? Okay. Somebody do the next one? Go ahead.
Well, I have a question. What's that font that divided by 0? That error?
I need a facial expression for this. I don't know. Maybe. I'm being coy. So, Megan, take this one. And I apologize for big numbers. 14 to 9, I do 10 times 9 and 4 times 9. Yeah, that's so much easier. Yeah, 126. Minus 42 times 3. Close. 126. What's the answer?
0.
Interesting. A sub y. Sam, it's downhill multiply minus uphill multiply. And I apologize in advance for the huge numbers. I do 7 times 40 and 7 times 2.
294.
Nice. 294. So actually it's negative 294. Yeah, you notice? Minus negative 294. What's minus a minus? Plus. What do you get? Wowzers. So find the solutions for me. X is A sub x over A determinant. Yeah. Becca, what is it?
0 for 0.
Yeah, how exciting is that? And then y, go ahead and do y while we're at it. That's A sub y over A, which is really switching things up.
0.
He said sarcastically. Yeah. What is 0 over 0? Oh, sorry, question. Yeah, go ahead. Sorry. What is 0 divided by 0? A lot of people are tempted to say 0. What do you say to that temptation? Get thee behind me, Satan. Katie. It's what? I wish. That's logical. In a sane world, it would. Yeah. It's undefined. Not because the top and bottom don't try to cancel each other. They do. But the fact that you're trying to divide by 0 at all explodes the problem. It's a little like saying, wow, they cancel and make one. And then you're sort of we've all been turned into like a radioactive vapor floating in the stratosphere because the nuclear bomb just went off.
But, writing is just multiplying by the denominator, and 0 and 0 to 1, so 0 to 1.
I'll show you that. The short answer to this is undefined, and I'll show you why. I know what you're talking about. Look over here. Does anyone remember from earlier grades how to check a division problem? Yeah.
You just put the X into the X and the Y into the Y, so
Well, that's clever, by the way. But let's just say I don't know, what it's like fourth grade or something. If they give you this, like 20 divided by 4, and you get an answer of 5, how do you check your work? Yeah, correct. It takes 4 times 5 is 20, right? You remember that from way, way back when? Let's try that over here. There's some argument that said 0 over 0 is equal to 1. Try the double check, see if it works. What's 0 times 1? It looks like it works. Like, holy mackerel, it's not undefined, it's 1. Now try it. Does it work? Yes. 0 times 2 is 0. But wait, there's more. I'm going to claim that 0 over 0 equals pi. Does it work? Yes. Part of the problem is, it's not that the solution, it's supposed to have one answer. A division problem is supposed to have one answer, it's a function. If you get more than one possible answer, it's not a function, it breaks down. So this is not undefined because we don't have any answers. It's undefined because there are too many. So there are actually 2 different ways to get undefined. And I'm actually going to show you a graph of this in a second. You'll understand perfectly. Now, the graph on this is horrendous. Just to kind of take my word for it. The x-intercept, I'm going to do chubby hand method on it. The x-intercept is kind of nice. It's 2. And that's where the niceness leads us. The y-intercept is, holy mackerel, negative 14 thirds. I invented this, right? Negative 14, what is negative 14 thirds? 3, 6, 10, 12. Negative 4 and 2 thirds. It's like down here. I'm just going to say negative 13 thirds. And there's the line for, there's line number 1. Now I'm going to graph line number 2. Does anyone remember the graphing method? Where do you find a solution to 2 lines when you graph them? Where they cross? Oh, I'm getting a little excited here. All right. Negative 20y to negative 42. Guess what the x-intercept is? Divide both sides by negative 21. It's 2. What a coincidence. And then the other one, 42 over 9, those actually reduce. 3 goes into both of them. That goes down to negative 14 over, or what did I put 13? I scare myself sometimes. So there's plainly a 14, isn't it? This turns into 14 over 3. Guess what? Can anybody tell me what kind of lines those are? Go. Well. Okay, go. Coinciding. They're coinciding lines. Now, it was mentioned earlier, and rightly so, that the solution is where the 2 lines cross. How often do these 2 lines cross? Everywhere, forever and ever and ever. There are too many answers. You cannot solve. You put undefined, but that is actually not good enough. Because undefined would also be true if you had like 0 and like 5 over 0. 0 over 0 is coinciding from Cramer's rule. How do we know that? We didn't. We discovered it just now. Well, I saw it last year. You see that? If you get 0 over 0 on Cramer's rule, stop, hit the brakes, and write the words, coinciding. That's what I want for the solution here. Those are coinciding lines. Are we okay? Now, I want to try one more. You can probably guess where I'm going with this. I'll make it smaller this time so it's not quite so brutal of mental math. 2x plus 3y equals 6. 4x plus 6y equals 2. I would like you to solve with Cramer's rule. That means I need a sub x, and a sub y determinants. Shaylee, what's matrix A determinant?
2, 3, 4, 6.
Go ahead and calculate that while we're at
12 minus
it. Interesting. What do you get?
0.
Okay. Do the next one while we're at it.
6, 2, or
Good.
6, 3.
6. Okay. Yeah, if you're going down, that's fine.
6, 2.
6, 2, and then 3, 6. Calculate.
3, 6, minus 6.
Which is?
30.
Hey, for a change, you got a non-zero number. Let me see. Megan, take over. Try a sub y. What's the first column? 2 and 4. And then 6 and 2. Go ahead and calculate.
4 minus
24 is what?
negative 20.
-20. Calculate the x and calculate the y for me, somebody who's feeling brave. Go. Oh. How do you get x again?
So x is the determinant of
A sub x over,
over the
Determinant of A.
Yeah.
what do you get?
We get 30 over 0.
30 over 0. That's exciting. We'll do that in a second. And then this is a sub y over a. What would you get there?
20 over 0.
Oh.
Oh, dang it, shoot.
Not that it's going to make a difference because it's going to die anyway, but that sounds really harsh. Who cares what its name is? It's going to die anyway. That just sounds heartless. But it's a math problem. So, what's 30 divided by 0? Math people? Josh?
Undefined.
It's undefined. You cannot divide by 0. And if you try the old-fashioned check the math trick, 30 over 0 equals something or other. Yeah.
So for one of these problems, like if you just found the determinant of A and just go, just stop and then just call.
Oh, the question is, if you find out the determinant of regular A is 0, can you stop? Yes and no. On the one hand, you know it's going to be undefined. But on the other hand, I want you to go one step further. And let me, first of all, just from 4th grade, 0 times something is 30. What's the something? Trick question. I don't either. And I'm not going to say let's find out. That's different. Story problem. But, Becca, what number times 0 is equal to 30? No number on earth. Correct. None. This was a problem because there were too many solutions. This is a problem because there are not enough. Not even one. We're out of luck. And this one is negative 20 over 0. Same problem. Let me graph these for you. X-intercept of 3, Y-intercept of 2. And this one has an x-intercept of, oh, I take E. An x-intercept of 1/2. I did that to myself. And a one, whoa, no, what am I doing? X-intercept of, yeah, 1/2. And then a y-intercept of 1/3. Yeah, I did that to myself. But take a look. Did you notice something? Courtney. The parallel. These are parallel lines. When you get something else over 0, that's a dead giveaway that this is parallel. And that's what I'd like you to write as your final answer on the Cramer's rule problem. So you're going to do one of 3 things in the Cramer's rule problem. You're going to give me a pair of letters, X or Y, or you're gonna say parallel, or you're gonna say coinciding. Those are the three options. Make sense? Yeah, perfect.
So the denominator and x and y equals 0, and but the numerator and x and y are different, but they're 0.
Correct. If you get 0 over 0, and pretty much it'll be 0 over 0 for both of them, it's coinciding. You will never get 0 over 0 for one and not 0 over 0 for another. They'll go together, or like united we stand, divided we fall. They stand together or they die together. It's kind of touching. So 0 over 0, coinciding. And if you think of it, 0 and 0, they're the same. If you have two numbers that are not the same and it's still a divide by 0, parallel. Does that make sense? You can remember that. That'll help you with the second part of homework 4C-5. And that, believe it or not, is all I have for you. So you have a little less than 20 minutes. Go ahead and pound away at that. It's conceivably you can get this done at the end of the hour. Go for it. Call me over if you get stuck. Otherwise, enjoy. Oh yeah, that's right, we're still videotaping. Okay, so people at home, I hope you've enjoyed. If you like this, click subscribe. And I did. So the senior class wanted me to do that, so I did. Click like and blah 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 blah. Anyway, get well soon, y'all. Bye.